Hopefully you are now familiar with setting up triangles, getting us ready for trigonometric substitution. So now we're ready to dive right into that. At the end of this lesson, you'll be able to evaluate an integral using trigonometric substitution. So we're going to go right into the examples. Notice this first one says the integral of dx over the square root of 4x squared plus 1. First of all, I'd probably check for a u substitution, and there is not one, because du is nowhere to be found. I would not use an arc formula because arctangent does have a plus sign but does not have a square root. Arcsine and arcsecant have square roots, but they have minuses instead of plus. So that means this type of problem is perfect for a trigonometric substitution. So what we are going to do is go ahead and start by setting up our triangle to get ready for that. All right, if you're familiar with setting up those triangles, we know that since there's a plus sign under the square root, that whole square root part is going to be my hypotenuse, so 4x squared plus 1, and then one of the sides will be 2x, and the other side will be 1. All right, now we're going to continue setting up our triangle. The next thing that I'm going to do is deal with where one has an x in it, so I'm going to use tangent, so tangent theta equals 2x over 1, and if I'm solving that for x, I'll get 2x equals tangent theta. So x will equal, I'll actually multiply both sides by 1/2, I'll get 1/2 tangent theta, and remember we have to find dx as well. The derivative of 1/2 tangent theta will be 1/2 secant squared theta d theta. And then the other thing that I do need to find is I would like to solve for the square root. I notice that that will involve the adjacent and the hypotenuse, and we'll use secant instead of cosine. So we have the hypotenuse up top, so I'm going to have the cosine of, I said secant. The secant of theta is equal to hypotenuse over adjacent, so I'll have the square root of 4x squared plus 1 over 1, and solving that for the square root of 4x squared plus 1, it will simply equal secant theta. All right, the reason that we did that is because now we're going to do a substitution. We're going to substitute in everything that we found. So I have an integral sign still. The dx, I found out the dx was 1/2 secant squared theta d theta. So I'm going to, in place of the dx, I'm going to put 1/2 secant squared theta d theta. And then down on the bottom, I have the square root of 4x squared plus 1. Well, I found out what that was, so I'm going to replace the square root of 4x squared plus 1 with secant theta. And now it's just become a trig problem for me to evaluate. So I notice now that I can cancel out one of my secants, and I'm going to bring my 1/2 to the outside, so I'm going to have 1/2. I'll be left with secant theta d theta, and then from here we have a formula for secant. It's equal to 1/2 the natural log of the absolute value of secant theta plus tangent theta. Okay, so I'm pretty much done. What I do need to finish out is my original problem asked me for an answer that was in terms of x, so I do need to put everything back in terms of x. So I'm going to have 1/2 the natural log secant theta. Secant theta, we already know from setting up my triangle that it was equal to the square root of the 4x squared plus 1. And then plus tangent theta, we did find out also that the tangent of theta was equal to 2x. And then I just need to add my plus c, and I am now done solving that trig problem. All right, problem 2, I have dx over the square root of x squared minus 9 minus x squared. Cannot do a u substitution. It looks pretty similar to secant, but in secant the variable has to come first. So this one, once again, is going to be a good setup for a trig substitution. We're not going to worry about that x squared being there. We mostly like that there's a square root of 9 minus x squared in our problem. So we're going to set up the triangle. So I'll have a theta, and then since there's a minus sign under the square root, I know that 9 is going to be 9 squared. The square root of 9 will be my hypotenuse, so that will be 3. One of my sides will be x, and then the other side will be that square root, so 9 minus x squared. And once again, although it doesn't really matter which one you put as the sides so that we all end up having the same answer, it's best to just put the x up there. Okay, so setting up the triangle, I'm going to start with the x first. I'm going to be using opposite and hypotenuse, so I'll be using the sine. So sine of theta is equal to x over 3. If I cross multiply, I'll get x equals 3 sine theta. So I've solved for x. Remember, I still need to find dx. So dx will be 3 cosine theta d theta. And then the other thing that I need to solve for is that square root. So I'm going to use, since this is adjacent and hypotenuse, again we'll use secant. It's going to be one of our popular ones to use. So secant will be, well actually I'm not going to use secant because I want the adjacent on top. So I am actually going to use cosine. So cosine theta will be the square root of 9 minus x squared over 3. I'm going to cross multiply, so I will get the square root of 9 minus x squared is equal to 3 cosine theta. All right, once I've found all my parts, again, I'm going to go back into this problem and substitute. So the first thing I come to is dx. So instead of dx, I know that dx is 3 cosine theta d theta. And I'm replacing every single part that has an x in. This next one, notice, says x squared. Well, I know that x is equal to 3 sine theta. So that's going to be 3 sine theta, and I'm going to square it. So now I've gotten rid of that part. And then the square root of 9 minus x squared I determined was equal to 3 cosine theta. So this will be times 3 cosine theta. All right, from here we're just going to clean things up. I notice that these 3's will cancel, these cosines will cancel, and I'm going to do a little work now. So I have d theta. If I distribute that square to both parts, I'm going to end up with 9 sine squared theta. Okay, now I'm going to bump the 9 out front, so I'll have a 1/9 on the outside, and then since I have sine squared down on the bottom, if I were to move that up top, 1 over sine squared is equivalent to cosecant squared theta, d theta, and we actually have a formula for cosecant squared. The integral of cosecant squared is equal to negative cotangent theta, so that's what I'm going to use. So this will end up equaling negative 1/9 cotangent theta. And then from here, the biggest thing that we need to finish with is that we can't leave thetas in our problems. We have to go back to x's. So I notice cotangent theta, I do not have a formula for cotangent. I know tangent is opposite over adjacent, so cotangent is going to be adjacent over opposite. So I'll have negative 1/9 times adjacent over opposite. And so if I just write those as one fraction, I'll have negative square root of 9 minus x squared over 9x plus c.